Hello, it is Summer Olmsted here, and today we're going to be doing another coding problem, so let's just get started. All right, so then I'll turn off my screen. All right, so we're going to be writing a program using recursion bisection search. So I have all my variables listed. In the previous video, we used a similar problem, but now we're going to be revising 2.3 to be doing this program prompt. So we have our variables here. We have the balance, annual interest rate, and we have the monthly interest rate, and we have a low and higher bound for our bisection search, and we have the payment of the average to use it in our bisection search. So what we're first going to be doing is I'm going to define a function by, I'm going to make this the answer of the overall thing whenever we run it later. So I'm just going to go ahead and put this here. It'll make sense sooner and I'll explain it. But now we're going to define the actual main recursion part. So we're going to have bisection is the name of this function. We're going to have some constructors, the variables that we need to have passed in right here. And as you can see, I had to match it with this because it's going to be returning this function. So, wait, I missed it. That's why I didn't indent. All right. So we're going to be following a lot of the same code I used last time. And we're going to just go ahead and write this all. And like I mentioned, this is just code that we used last time. Sorry, I'm a slow typer. All right. So let me think. Minus a payment. So this is what we're gonna get to like get what it'll be paid each month as it goes through for each time in the year. All right, here is going to be our if statements and where we're going to start using the recursion aspect of it. So this is similar to my last if statements, but instead we're going to be returning this function, calling it by the function itself again to start all over for a return statement inside this. Let me finish writing this. All right, so we're going to be returning. This is in the scenario that this is the perfect payment to pay it off in 12 months, like no interest or anything like that, like the perfect number to pay it. So what we're going to do is this is going to be our rounded answer. This is going to be in the scenario that we found the correct answer. And what we need to do now is give the payment. So whenever the answer function is using the bisection to return it, it's going to be returning this answer. So I'm going to round the answer. So it'll be the correct format. And now we're going to go to the next one. All right. So now what we're going to do is we're going to be calling the function we're in itself, and we're going to, since it's higher than 1, we need to make the lower bounds become the payment that we're currently working on. So we're going to change by these constructors here where we have the balance low high. We're going to now input we're gonna have the same balance, of course. And now we're gonna change the payment to the low, and then the high is gonna stay the same. So yeah. And now we're gonna do a similar thing for the next, but we're gonna change one aspect of that. All right. So now let's just print. I'm gonna write this, but I'm gonna explain it better after I write this last part. So our initial balance is 5,000. All right, so what this is all doing is, let's first dissect here. This is a function where we need the inputs of balance, low, and high, and these are the bounds, of course, and then it's going to be rechecking to set the new b to the balance, and it's going to have the payment be based on the lower and higher bounds average. So it's going to have this iteration here of the loop of the 12 times, and if the new balance, this is pretty much just doing the math of whenever the new balance is subtracted from the payment, and it's going to have the interest there to have what the new balance is by using this payment we just used for the updated version. And we need new b to be in this range to be considered the correct answer. And if it's too high, then we're going to end up lowering the payment. And if it's too low, we're going to make the higher bound more adjusted to the payment. And then what it's going to be doing is it's first going to be running the function of the answer, which has just the balance, and we're going to be inputting 5,000 because that's our original balance. And it's going to be returning the bisection function, which has the parameters balance, low, and high. So let's run it and see how it goes. The first time, it always takes a second. All right. So our answer here is 451.61 cents, which is the correct format we were looking for. And this is the answer we were looking for, as we've seen in 2.3. This is the correct answer for this prompt. And we're pretty much using a lot of the similar code to what we did last time, but we're just going to tweak it a little bit to add that recursion aspect. Just to clarify, overall, we pretty much just added two functions here, and we needed the functions to call itself. So what we did here in the if statements, while we're using the bisection search, we need to have return statements to, well, the first one here is to return if it's the actual correct answer, and the other two is returning it to adjust the higher or lower bounds to help us find the correct payment for the end. And we have this other function here, which is our way to get the final answer, and we're going to just input any balance, and ours, of course, is 5,000, and it's going to be returning the bisection function and then it would lead it to do all of this until it returns us to the correct one as it goes through and keeps on calling itself. It'll eventually lead us to this if statement, which will return the correct payment, which is why we got the correct answer here. Thank you so much for watching, and I hope you guys have a great day, and thank you.